Okay, today we're going to be looking at the mean. And what we generally mean about the mean is the arithmetic mean. Before we go into it in any great detail, we're going to look at a couple of pieces of notation. So when we're going to be calculating the mean, we're going to use this piece of notation. This is the Greek letter sigma, and we use it for to represent sum. And the other piece of notation is if we have x with a line above it, this means the mean. So, given these pieces of notation, we're now going to look at how to calculate the mean if we have ungrouped data and grouped data. So the ungrouped data is when we have just the raw data, but group data is when we will be dealing with frequency densities. So the sum is going to be, we're going to use sigma in both of them. So when you see sigma, you mean you're going to sum those values. The data values are x and x. The frequency of data values. This does not matter for the ungrouped, but for the group data, it's the frequency is f. The number of data values is going to be n for ungrouped, and for group data we take the sum of the frequencies, and then the sum of data values is going to be the sum of x, and for the group data we take the sum of the data values multiplied by the frequency, or the sum of f times x. And then the mean x bar is the sum of x of the data values over n, the number of values for ungrouped, and the mean for group data is going to be the sum of x f, so the sum of the data values, divided by the sum of the frequencies. So let's look at some examples. First one's quite a simple one. 5 labourers whose mean mass is 70.2 kilograms wish to go to the top of a building in a lift with some cement. Find the greatest mass of cement they can take if the lift has a maximum weight allowance of 500 kilograms. So we know that the mean is equal to the sum of the values over the number. Now we know that the average, the mean mass is 70.2, and we know we've got 5 labourers, so we can find the total mass of all the labourers put together. So that is going to be 70.2 multiplied by 5, which is 351 kilograms. Now, the weight allowance is 500, so 351 plus y, where y is going to be the maximum weight of cement, can't exceed 500. So y would be 149 kilograms. So that's the maximum weight of cement that the men can carry up with them. Now let's look at a problem using group data. So find the mean of 40 values of x given the following. So x can be 31, 32, 33, 34, or 35. And the frequency of these values is 5, 7, 9, 8, and 11. So that's what we're given. Now, we need to find the values multiplied by the frequency. Let's just do this very messy table. So we multiply these, you'll get 155, 224, 297, 272, and 385. Now we need to find the sum of the frequencies, which is 40, and we need to find the sum of the data values, which is sum of xf, and that is 1,333. Therefore the mean is equal to the sum of the data values over the sum of the frequencies, which is 1,333 over 40, which is 33.325. Oh, excuse me, I've got hay fever tonight. So, let's now look at combined sets of data. Now, this is when we get two sets of data and we want to take them and put them into one set. And there's different ways to do this, but we're going to look at quite a simple way to do it. So say we had a data set. We've got one data set, and that is 1, 2, 3, 4. That's our first data set. And our data set 2 is 4, 5, 6. Now here, the mean of this is going to be 1 add 2, 3 add 4 over 4, which is 2.5. And the mean of this data set is 4 add 5, 6 over 3, which is 5. Now, if we were to combine, the combined data set is 1, 2, 3, 4, 5, 6. So there's 2 4s, 4 here and 4 here, so we need to repeat 4. So we've just taken this data set and put it together with this data set. Now, the mean of this data set is now 1, add 2, add 3, add 4, add 4, add 5, add 6, all over now 1, 2, 3, 4, 5, 6, 7. Over 7, but we've had our 4 add 3 here, is going to be 3/4. Now, you cannot do this. This is not the mean. 2.5 plus 5 over 2 is not the mean. So if you just took the mean here and the mean of that, that's 2 values, add them together and divide by 2. That does not give you the mean of the combined data set. This is not the way to do it. You have to take the raw data and deal with it as a new set of data. Let's have a look at a couple of examples working with combined data sets. So, a large bag of sweets claims to contain 72 sweets with mass 852.4 grams, so with total mass, sorry, should make that clear. A small bag of sweets claims to contain 24 sweets, having total mass 282.8 kilograms. What is the mean mass? So, what is the total? So first of all, we need to find is what is the total mass of the sweets. So if we took all the sweets in the large bag, all the sweets in the small bag, and combined them into one big bag, you would have 72 plus total mass, total number of sweets firstly. 72 plus 24 sweets, which gives us 96 sweets in total. Now the total mass, well, that's going to be 852.4 plus 282.8, which gives us 1,135.2 grams. That's not meant to be kilograms, that's meant to be grams. So the mean mass is going to be the total mass of all the sweets put together divided by the total number of sweets, which is 11.825 grams. Let's look at another example. A family has 38 films on DVD with a mean playing time of 1 hour and 32 minutes. They also have 26 films on video cassettes with mean playing time of 2 hours and 4 minutes. Find the mean playing time. So, how many films are there? Number of films is 38 plus 26, which is 64 films. Now we want the total mean playing time. So we've got hours and minutes and hours and minutes. We're going to turn, these are going to get converted into minutes. So if the mean playing time of the 38 films is 1 hour and 32, 38 times 1 hour and 32 minutes is going to give you the amount of playing time for all the videos on DVD. And we're going to add that to the 26 films multiplied by 2 hours and 4 minutes. So that's the amount of playing time for all these video cassette players. Now we're going to put that into, this is going to be 92 minutes, and this here becomes 124 minutes. So the total mean playing time is 6,720 minutes. So the mean playing time will be the total playing time divided by the number of films, which is 105 minutes, or 1 hour 45 minutes. Now, the mean from grouped frequency tables. Now when we've got our data as a group frequency table or as a histogram or a cumulative frequency graph, we lose the raw values. For this reason, we can't determine the exact mean, so the mean will be an estimate. And we do this by using the mean value in each of the classes. So the mean value is the sum of the values times the frequency over the sum of the frequency, where x is the class mid value. So let's look at a couple of examples. Coconuts are packed into 75 crates with 40 of a similar size in each crate. So there's 46 crates contain coconuts with total mass from 20 up to, but not including 25 kilograms. 22 crates contain coconuts of mass 25 up to 40, but not including 40, and 7 crates contain coconuts from 40 kilograms up to 54 kilograms. That's the total mass of the coconuts in a crate. It's not like an individual coconut with a mass of 54 kilograms, because that would be like a child-sized coconut. So firstly, we want to calculate an estimate of the mean mass of a crate of coconuts. And secondly, we want to use this answer to estimate the mean mass of a coconut. I'm going to need to get another page up to do this. So first, we're going to put this into a table. So we've got our mass in kilograms of our crates. So we've got 20 up to, but not including 25. Then we've got 25 up, and then we've got 40 to 54. Now we have the number of crates, which is our frequency, and we had 46, 22, and 7. Now we can find the sum of the we'll need the sum of the frequencies, so that's going to be 75, and now we need to find the mid value. So the mid value is, in each range, what is the mid value of the mass? So here, between 20 to 25, it's going to be 22.5. Here, between 25 and 40, it's going to be 32.5. And between 40 and 75, it's going to be 47. And now we need to find x multiplied by f. So in this one here, because it's ungrouped, we use the mid value, it's going to be our x. So these two multiplied together is going to give us 1035. This will be 715, and this will be 329. And now we need to find the sum of xf, which is 2079. So the estimate of the mean will be the sum of xf over the sum of f, which is 2079 over 75, which is 27.72 kilograms. Now, the estimate of a mean mass of a coconut will be our answer to this. Our mean mass, 27.72 divided by 40, because there's 40 coconuts, which is 0.693 kilograms. Let's look at one more example. So calculate an estimate of the mean age of 50 students where there are 16 18-year-olds I'll write that in words because we have all these numbers. 20 19-year-olds and 14 who are either 20 or 21. So we're going to do our age, and we're going to write that as a range. So for 18 to 19, so it's up to 19 but not including 19. And we have 19 less than or equal to the age up to 20. And then we have 20 less than or equal to the age A less than 22, because it can be 20 to 21 but not 22. Now we need to find our mid value. So here is 18.5. Here it's going to be 19.5. And here it's going to be 21. And now we've got the number of students. (16, 20 and 14). Now the So the number of students is our frequency. So we can do the sum of the frequencies is going to be 50. Now we need to find our mid value multiplied by our frequency, which will be 296, 390 and 294. And now we need to find the sum of our mid value times frequency equals, I'll write it here, 980. So the estimate of mean age is equal to the sum of the mid value times the frequency over the sum of the frequencies. So it's 980 over 50, which is 19.6 years. Now, it's good to note the boundary values. For the true mean are going to be, with the lower boundary is 18 times 16 plus, so 18 is the lowest age, 16 is the frequency of students in that value, in that range, plus 19 times 20 plus 22 times 16 all over the 50 students. So that's assuming that that within this value of, so when we're finding the lower value, the lower boundary, we're assuming that in each of the ranges that all the students are at the lowest level within that range. So the lowest value of the true mean could be 18.96, and the upper, so we do the same but in the opposite, so we take the upper limits, so it'd be 19 times 16 plus 20 times 20 plus 22 times 14 all over 50, and that is 20.24 years. So this is our estimate of our mean. This is the lowest possible value of the mean, and this is the highest possible value of the mean. So I hope that makes sense.